Hello class, it's Mr. Ng and I wanted to give you a short little video to walk you through the analysis of your aluminum lab. So by now you should have all of this stuff filled out, right? And here you should have the averages of all of your data, meaning you added these three numbers and divided by 3 and put it over here. Those are your averages. So we're going to use these averages and treat them like our givens, and we're going to use the density of aluminum as a conversion factor. Here's what I mean. So when you weighed that little piece of aluminum, you found out that one of the pieces might have weighed around 0.23 grams of aluminum. This doesn't really get us to the thickness of the aluminum, but we can find the volume of this aluminum, meaning we're going to find how much space does this aluminum take up. And we're going to use the density right here as the conversion factor. To get out of grams, we're going to divide by grams. And we're going to get into centimeters cubed with this here density, right? 2.7 grams is equal to 1 centimeters cubed of aluminum. And as you can see, grams cancels, and I'm going to be left in centimeters cubed. So it's just 0.23 divided by 2.7, and I get 0.085 centimeters cubed of aluminum. Great. This is our volume. This is how much space that little foil square you had takes up. So do that 3 times over with your own data and give me the actual volumes nice and neat on the bottom here. And this volume is going to also be our next given, right? We're going to use this number in our next analysis. Here we could use that volume to figure out the thickness of a piece of aluminum. Here's what I mean. So imagine I blow up your little foil square into something much thicker. And we have a base, we have a length, and we have a height. Those three things multiplied together is the volume. The volume is equal to base times length times height, right? Our volume is equal to, and all I had to do was measure it with a ruler. This is 7.1 centimeters, that's the base, times 7.1 centimeters, that's the length. I measured this with a ruler, times the height. This is the one that we want to know, right? How thick is this piece of aluminum, our H, our thickness? And of course, V, we can fill this sucker in, right? V is going to be this number up here, 0.085, right? So, but let's simplify it. And let's give you a derived equation. So V is equal to 7.1 times 7.1. I got 50.41. 50.41 centimeters squared times H. So if I needed to solve for H, solve for how thick it is, H is equal to your total volume divided by 50.41 centimeters. So if I use the numbers from up top, 0.085 centimeters cubed, right? 0.085 centimeters cubed divided by 50.41 centimeters squared. Notice that these guys cancel out, so I'll only have 1 centimeter as my unit. This is 0.085 divided by 50.41, and I got 0.0017. 0.0017 centimeters. Really, really tiny. So I challenge you to convert this to millimeters, millimeters, or maybe even micrometers, right? 1 millionth of a meter, okay? So, and that's actually one of your discussion questions. So after you do your little math up here, right? So do your own math. I gave you a sample. Do it 3 times over with your own data. Great. Find how thick each piece of aluminum is. Next, come down here and then I want you to figure out, write me a strong evaluation. Which one's the best value? Go online and look up the prices for these foils. Is that extra thickness of foil worth the extra couple of dollars? Give me a strong paragraph here. And lastly, choose the right unit. Is using centimeters appropriate? I mean, it was 0.001617 centimeters, right? Is that the best way to write this number, or are there more convenient numbers? What's the most appropriate unit for describing the thickness of aluminum? So that should take you a little bit of time. Take your time with it. Write well. I want you to write deeply. I know I haven't been doing the best job reading everything, but I do really want to read this one, so work hard, please. And thank you very much for watching.